Next question. So when you have an integral and you have a square root in the denominator, these are the three identities that you should immediately think about. We're going to try to fit what's under the radical here into the formula for one of these identities. We have the integral of 28 divided by the square root of 18x minus x squared dx. First, let's bring the 28 outside of the integral. Which gives us 18x minus x squared dx. And with these types of problems, when there's a radical in the denominator, and specifically what seems to be, or what can become a quadratic, we want to make this into an actual quadratic of the form ax squared plus bx plus c. So let's bring out what's under here, 18x minus x squared, and let's try to make it into a quadratic. First, let's factor out a -1 so that we can get this to the front and have it be positive. So x squared minus 18x. And now we want to complete the square to make this into a quadratic. To do that, we divide this term by 2, the b term by 2, and then square it. But now that we've added the 81 in here, realize that we've actually subtracted 81 from the entire equation, since there's a negative out here, so this is really negative 81. To balance the equation, since we can't just subtract 81, we need to add 81 as well. So this becomes 81 minus, and then this quadratic, which we can collapse into x minus 9 squared. And that's just a formula. Now let's put this under the radical. Now let's look back to our inverse trig formulas. This fits the arcsine formula. We can set x minus 9 equal to u, and we can set 9 equal to a, since a squared is 81. Nine squared minus x minus 9 squared dx. So from our trig formula, we can set a equal to 9, u equal to x minus 9, and du simply equals dx. So 9 is a, x minus 9 is u. This means that we can substitute an arcsine of u over a, which is x minus 9 over 9 plus c. This is the final answer.